Okay, now it's time for an arc length calculation. Chapter 2, Section 5 from our supplemental book, Problem 176. We're asked to find the arc length of the curve 1/3 x cubed plus 1 over 4x from x equals 1 to x equals 3, and I've prepared the sheet with the standard arc length formula that we are going to use. Hopefully you've read the notes at this point, and you can see that when I do the solutions to these, I tend to do some planning ahead. I don't just start building this entire monster all together and carry it through. I assemble the bits and pieces that are going to go into this before loading it up into the integral. It just is cleaner that way. So, y equals and f of x, same thing. So I'm just going to start building up to what we have to integrate. So the original function is 1/3 x cubed plus 1 over 4x. The derivative, f prime, is then going to be, this is easy, bring down the 3, get x squared, and then minus, this will be 1 over 4x squared, because this is 1/4 times x to the minus 1, so the derivative is negative 1/4 times x to the minus 2. All right, now we got to square this thing. Ugh. Well, when I square this term, I'll get that times itself, which is x to the 4th. I will get this times itself at the tail end. And then I'll get 2 of the cross terms. So minus 2 times x squared times 1 over 4x squared. Like so. And clean this up a little bit. We're going to have x to the 4th and 1/16 x to the 4th on the wings. And then in here, a little cancellation there. And oh, look, the x squareds cancel too. So this all shakes out to minus 1/2. Then we're going to build 1 plus that. And so that'll be x to the 4th plus 1/2, because negative 1/2 plus 1 is plus 1/2. And then nothing changes for the last item. Now remember that we need to take this and plug it into this integral where there's this big giant square root sign waiting for us. So we're going to take the square root of this before we integrate. Wouldn't it be wonderful if this happened to be a perfect square? Because then when we took the square root, it would simplify very nicely. And it just so happens a lot of problems are designed like this. That this thing right here, if you roll it backwards, is a perfect square of that quantity. So x to the 4th plus 1/2 plus 1 over 16x to the 4th is the square of the term x squared plus 1 over 4x squared. And so I'm getting close to the bottom of the page, so I should be good and I should present the square root of this as its own thing, but I'm running out of space. Of course, if I was preparing this for submission, I would of course rewrite it anyway to make more space. But ultimately what I'm looking at here is an integral from x equals 1 to x equals 3, because remember it's up there. The square root of this thing I just created, and the square root of that is just the interior, like that. And kind of like the area between curves, the evaluation of this particular integral is trivial. It's power rules. So I'll leave it to you to practice if you want. We can put ... I can put ... Teacher's prerogative. I will point out that many of the problems that you'll tackle, the evaluation of the integral may end up involving substitution, trigonometric substitution, because you're doing a square root of 1 plus something squared. And so that tends to lead to forms that might require trigonometric substitution. But there's a couple of examples of that in the notes. So I'll leave it at that.